Welcome. Let's talk about fractions for a second. So fractions are probably something that scare you. They scare most people. And I think part of that is we don't understand them. We look at them as just simply algorithms. We understand proportions and ratios. We're going to get into this a lot as we continue to go through this more and more. We're going to introduce the basic ideas in this video. It won't be comprehensive. Please look over your book. Please read the other readings and come ask questions because that's what we're here for. All right, so let's talk about the different parts. The top of a fraction is called the numerator. The bottom is the denominator, and there's a funky line in the middle, the vinculum. You don't have to memorize that. It's just a random fact. All right, so what are fractions? Well, and how are they used? Well, fractions are something called rational numbers. Rational numbers because they are a ratio. So one of the key things about rational numbers is they are a division. So often they are used as a representing division. So 3/2 is 3 divided by 2. That's what that means. Similarly, it can be talked about as a portion. This is sometimes we often talk about just portion concept. We cut out circles and other things. That is great. It's not a full picture of what they can actually use. But it is great to use them because that is actually one of the applications we have. And then we have ratios. A ratio is comparison of things and so forth. We'll get to this example a little more. But again, understanding that we have to keep the ratio balanced, or else we're off. And last but not least is probability. But again, we will get to that when we get to the probability and statistics. But I want to put it out there anyways, because probability still should make sense. All right, so let's look at some visuals. So this right here are 3 different visuals that are used to help students understand fractions, especially when they're first starting. So in my first area model, I have something that's broken into 3 equal parts. One of the parts is colored in. That makes it a 1/3. That makes it a fraction of 1/3. The next one has 2 parts out of 3, so that's 2/3. The last one has 3 out of 5 total parts, so it's 3/5. So fractions are parts of something. That's where that ratio and proportion start to make sense and help people understand some stuff super well. Now, with fractions, we often have a couple different kinds of fractions. We have called proper fractions, which means the numerator is anywhere from 0 and it's smaller than my bottom. On the other hand, we have a improper fraction if the top is equal to the bottom or it's bigger. Now, the reason that's important is because this actually allows us to kind of see things and understand more or less the different kinds. Neither one's actually bad. Some teachers really hate improper fractions. You want to use mixed numbers. I don't fully understand that because there's actually a lot of things where improper fractions are more useful, especially when we're doing the computations. Now, I do understand that mixed numbers are nice to give us an estimate because we can see how the full number is. But again, none of these are perfect because they have strengths and weaknesses. Now, let me visually understand this. If I have a number line where here's 0, -2, and 2, these numbers that I've put on the chart are between stuff. And you'll notice that part of this idea is because over here, there are 4 dashes between 0. There's 3 dashes, but that's 4 parts. 1, 2, 3, 4. And I move 1 part, so it's -1/4. On the other hand, 1, 2, 3, 4. So this is 1/4, 2/4, 3/4. So when we do this, it kind of helps make this understandable a little better. Let's do another visual kind of effect. So this is 1/3, 2/6, and 4/12. They are the same thing because you can notice, in essence, what I did to get from the first one, 1/3 to 2/6, is I cut each of the sections in half. That's where the dotted lines come in. To get to 4/12, I cut each of those things into 4 parts. Well, 1 times 4 is 4, and 3 times 4 is 12, because 1 part just became 4 parts because I cut it into 4 chunks. And the other 3 chunks, each of them got 4, so 4 times 3 was 12. This actually helps us see that these are equivalent fractions. Now, another thing they use a lot and seeing more and more in textbooks is what's called a fraction script. And this is great because you can see the ratio of stuff really, really good to compare it. Almost like a number line, but it's an area thing at the same exact time. And also we can see easily that to go from 1/2, there is no 1/2 is 3/6 because we simply cut this into 3 parts. So 2 divided by 3 is, 2 times 3 is 6. And again, if we split each of these 6's in half, we get 12, and we can count out all the different parts. All right, now this gets to a fundamental law, and that is, if I want any fraction, if I multiply both the numerator and the denominator by the same number, that gets us to our answer. That does not change our fraction. The ratios and proportions remain the same. So here, let's take this example. I want to find x. You can use a box if you don't like x. 12 over 42 is what over 212? Well, what I'm really asking here, to be honest, to solve this, part of the question I have to ask is 42 times what equals 210? Now, we know from we learned about division that we can say, well, that what is equal to 210 divided by 42. Well, I can execute this division. There's lots of different ways to do that. You quickly learn this is actually equal to 5. One of the easy ways to see that, by the way, is that if you double, this is a quick notation, 210 times 2 would be 420. So it's half of 10 times 42. Well, half of 10 is 5, so thus this number is 5. I know that's a little mental math, probably a little weird. Actually, again, that's manipulating things to our advantage. But once I know it's 5, then I can simply do this. I can simply say, well, 12 times 5 is 60, 42 times 5 is 210. Because my denominators are the same, that means the numerators must be equal, and thus my number is 60. And this is very, very useful to kind of get us to manipulate and change functions. All right, I'm going to cut off this fraction video, come back to the next fraction video, learn more about how we add and multiply.